Okay guys, so today we are talking about linear transformations. So transformations of the linear parent function. Here's a picture of it right here. This is the linear parent function. And we need to remember that the equation for the parent function is f of x equals x. Remember, another word for f of x is y. So y is equal to x. So we want to notice that on the parent function here that's graphed for us, the slope of the parent function is 1, because I can rise 1, run 1. So 1 over 1 is equal to 1. And I also can notice that just by looking in front of x here, there is the number 1. Invisible, but it's there. So we know that slope is always in front of x when our equation is solved for y, or f of x, because f of x is just another word for y. So we know that our slope of the parent function is 1, and we also can see that our y-intercept right here is the y-axis, and our line crosses the y-axis here at the origin, so our y-intercept must be 0. So those are important to understand when we're looking at transformations. We talked about transformations were just another word for changes. So we're talking about changes to the parent function. We open up on the inside. Again, we have our parent function right here. And the change that we want to see is if we take our slope and we make it negative. So what happens when we have a negative slope? Well, we know those lines begin to decrease. So if we take the parent function and we make it have a slope of negative 1, well, we didn't change the y-intercept at all. We simply changed the slope from positive 1, rising 1 over 1, to negative 1. So instead of rising up, I could go down and still run right. I could go down again and run right if I wanted to. Or, from the origin, I could rise up and run left. Remember, we have to change one direction when we're plotting a negative slope. So then if I connect those lines there, I see what happens when I reflect the parent function. I get this function here. I get a negative slope, a negative 1 slope. Okay, so now I want to talk about what happens if we do something called a vertical stretch. So we need to think of this as taking this line right here and stretching it up from top to bottom. You can almost think of a rubber band. We have a rubber band for our parent function here. I have a rubber band. There's my parent function, and I stretch it up this way from top to bottom. I get a vertical stretch. Well, notice what happens when I stretch it up from top to bottom. It's almost as if I squeezed it in on the sides, and it made my slope, what? More steep. Now I have a steeper slope. So a vertical stretch can also be known as a horizontal compression. We use the word compression, and you can think of like compression socks that squeeze your legs, squeeze the muscles of your legs to provide more blood flow, more support for your muscles. So a vertical stretch is going to give us a steeper slope. Well, that happens when this value here, instead of our slope now being 1, like on the parent function, our slope becomes some value a. When that value, that a value, is greater than 1, well, then we get a vertical stretch. Our slope becomes steeper. So let's pick a value. What if we said f of x equals maybe 3x? 3 is larger than 1. So the slope here is going to be 3. My y-intercept didn't change. It's still going to be 0. So now I'm going to plot this new line, this transformation. I'm going to plot it next to the parent function that's already here for me. So I still have my slope, my y-intercept of 0, but now I'm going to plot the slope of 3 over 1, right? We can change any number to a fraction by putting it over 1. So I start at my y-intercept, and I rise up 1, 2, 3, and I run 1. And if I want a second point, I can do that again. 1, 2, 3, run 1. So then here is my new transformed parent function. And you can see that slope is much steeper. So that's what we call a vertical stretch. or a horizontal compression. Like you're squeezing it in this way and making it almost looks like a thinner line. Okay, so then what if we had a vertical compression? So instead of my parent function being this, what if I squeezed it down like this? It's harder to see with the rubber band. But if I have my parent function and I squeezed it in, it's almost going to make my slope less steep. So you can think of this also, instead of a vertical compression, squeezing it down from top to bottom, what if I had it and I stretched my line from side to side? Do you see what happens with the rubber band? So instead of vertical compression, I could also think of this as, here's my parent function, and if I pull it horizontally, you can see that that becomes a vertical compression or a horizontal stretch. I'm going to do this in a different color. So vertical compression or a horizontal stretch. Okay, so for a horizontal stretch, I want this A value here to be greater than 0, but less than 1. So what if I chose a function like f of x equals, now let's pick a slope that again is greater than 0, but less than 1. So what if I chose 1/4 x? 1/4 is definitely bigger than 0, because I'm not trying to make a reflection. If I chose something that was less than 0, it would be negative, and I would have a reflection as well. But I just want to see what happens if I have a horizontal stretch, and I make my slope less steep. So if I choose 1/4, it's greater than 0, but it's less than 1, right? It's a smaller slope than our parent function, and remember, our parent function has a slope of 1. So I didn't change my y-intercept, but now my slope is 1/4. So I start here at 0, and I rise 1, and I run 1, 2, 3, 4. Now if I want to plot a third point, I could rise 1, 1, 2, 3, 4. 1, 4. And as you can see, that is going to be a much less steep line. So that's what we call a horizontal stretch. So I take my parent function, and if I stretch it this way, right to left, horizontally, it becomes less steep. For a vertical stretch, if I pull it from top to bottom, it's going to become much steeper. Okay, so now I want to talk about vertical shifts. We can shift functions up or down. So when we're talking about the parent function, if we want to shift it up, we would just add a value on the end. So we notice the parent function here again crosses at the origin. So the y-intercept is 0. So let's choose. What if we want to shift this parent function, f of x equals x, maybe we want to shift it up 2 units. Then I can add 2. Well, notice our slope here is still 1, but what's the b value now? What's the y-intercept? Remember, it's always the number that's added or subtracted onto the end. So now our y-intercept becomes 2. So the parent function, the y-intercept, is 0, but I move up to 1, 2, because that's where I wanted to shift my line up. So vertical shift up becomes a y-intercept at 2. Now we don't shift lines left to right. It's harder to see. So we always think of lines shifting if they're going to move. We think of them moving up or down. But notice my slope is still the same. It's still 1, or 1/1. So I rise up 1, and I run 1. Rise up 1, run 1. And I can see my line forming right there. So if I connect those points, I notice I have a line, and it looks like it's going to be parallel to my parent function. So maybe I don't want to shift it up. Maybe I want to shift my line down. So I could take my parent function, and guess what? Instead of adding a value, maybe I want to subtract a value. Maybe I want to move it down 3 units. So instead of the y-intercept being at 0, from there I will move it down 1, 2, 3 units. And again, I didn't change the slope. The slope here is still 1. Now my y-intercept is -3. So I can, from my y-intercept of -3, rise 1, run 1, rise 1, run 1. And I can see that line forming. And that looks like it's going to be a line that is parallel, again, to our parent function. Okay, so now let's try to take all of this and put it together. So the problem zone here at the bottom says, write a linear equation with the stated transformations. Well, first of all, it's telling me that it wants an x-axis reflection, it wants a vertical stretch, and it wants a vertical shift down. So again, we're doing all of this to the parent function. So I have f of x equals x. That's my parent function. So to perform these transformations, well, it wants an x-axis reflection. And we remember from up here, an x-axis reflection just means that I flip the line over the x-axis, tump it over, and all I'm going to do is put a negative slope there. So I'm going to have a negative slope to have a reflection. Now it wanted a vertical stretch. I need to remember that for a vertical stretch, that's where I take my line and I stretch it from top to bottom, and it becomes a steeper slope. So I need an a value that's greater than 1. So we can choose an a value greater than 1. Maybe I want to do 5. I have negative 5x, but I also have to have a vertical shift down. So in order to shift down, I need to subtract a value. So maybe I want to shift it down 10 units. So there I have a reflection, a vertical stretch, and a vertical shift down. So for this problem here, we need to identify the changes, the transformations that have happened to the parent function. So I need to remember that my parent function is f of x equals x. I need to compare this function to the parent function. So I notice in my parent function, my slope is 1. Remember? We have a slope of 1 and a y-intercept of 0 for the parent function. But for this function here, I can look in front of x and I see that my slope is what? Well, it's 2/5. It's the value sitting in front of x. And because that value is greater than 0 but less than 1, I know this is a horizontal stretch. So I'm going to have a less steep slope. I'm stretching it from right to left horizontally. So I have a horizontal stretch. And then I also notice here that I've added 3 units onto the end. So this means that I have a vertical shift. We add a value onto the end. We change the y-intercept from the parent function of 0. This means that my y-intercept for this equation is 3. So that is a vertical shift up 3 units. And those are the 2 transformations that have happened. The only other transformation that I can look at would be, has it been reflected? But because there is no negative in front of my slope, I know there was no reflection.